Welcome back to Chapter 7. We will continue with the Chapter 7C, the third lecture of Chapter 7 with chemical reactions and equations. 7.3, in this section we are going to talk about oxidation and reduction reactions. So if you recall, I brought that up in the previous lecture where I said I will talk in the future about individual reactions in double replacement reactions or single replacement reactions where we have individual oxidation and reduction reactions. So our learning goal is to define the term oxidation and reduction, identify the reactants as being oxidized or reduced. For example, rust forms when oxygen in the air reacts with iron. In this process, what's happening is there's an electron transfer between the two different elements. So electrons are being transferred from one substance to the other. An oxidation reduction reaction provides us with energy from food. So these are basic chemical reactions that occur in our body. It breaks down food and it generates energy from food. It provides electrical energy in batteries. It occurs when iron rusts as well. There you go, sorry. So iron solid plus oxygen gas react together to give us the ferric oxide, which is rust. And this happens, this reaction, the underlying reasons of this reaction and the mechanisms of what's going on is that there's an electron transfer from one reactant to the other. So in an oxidation reduction reaction, electrons are transferred from one substance to another. So let's take A, is the reactant A, and then there's the reactant B. And then there's product A, and then product B. What happens is the element or the reactant that gives an electron is the one that's being oxidized. The reactant B, which gains an electron, is the one that is being reduced. So A lost an electron and B gained an electron, right? The process or the reaction where there is a loss of an electron is called an oxidation reaction. The process or the reaction where there's a gain of an electron is called reduction. Okay, so B was reduced, A was oxidized. Okay, so let's take this short way to remember it. Oil rig, oxidation is loss, reduction is gain. Okay, try to remember it. Oil rig, oxidation is loss, reduction is gain. Okay, that's an easy way for you to remember. So the green panel on the Statue of Liberty is due to the oxidation of copper metal as it forms a green solid, copper oxide. Have you ever wondered why does it have that green color? It's because of that. There's an oxidation reduction reaction that's happening and turning that copper metal into an actual green solid, copper oxide. So what is the reaction? So copper metal is turning into copper oxide. What's happening in this process? So we have a copper solid plus oxygen, because in the presence of oxygen, it gives us copper oxide. So here we had a copper solid, which was initially a solid that has a charge of 0. Now we have it in an ionic compound where it is, this ionic compound is composed of a cation, which is Cu2+, and an anion, which is O2-. So Cu turned into Cu2+. So what happened here? So Cu solid turned into Cu2+. It means that it lost 2 electrons, right? It lost 2 electrons. And again, we balance these oxidation reduction reactions, and I will show you how. It's just very similar to what we learned in the previous lecture. So it's actually the same, but we have to make sure that the charges are balanced as well. So we have copper solid giving us copper 2+, therefore it's a loss of electrons, therefore it's an oxidation reaction. So this one turned into Cu2+ plus 2 electrons. Now when we balance the equation, we add a coefficient because we have Cu2+, okay, and then when we balance this entire overall reaction, we know that on this side we have 2 copper atoms, on this side we have 2 oxygens. On this side we have 1 copper and 1 oxygen, initially without the coefficients. And then we start to balance our equation. We say that if we have 2 copper atoms here, we have 2 copper atoms here, we're good. But we have 2 here and 1 here. So we add the coefficient here to make it 2 oxygens. Now the oxygen is balanced, but the copper is not. So 2 copper, we can add 2 on this side and make it 2 Cu plus O2. Okay? Now if we have 2 Cu plus 2 Cu2 plus, because there's 2 copper 2+ ions here, therefore, if each one is losing 2 electrons, then in total they are losing 4 electrons. This is the oxidation reaction. What's happening to oxygen? Oxygen, which is neutral, is turning into a negative ion. It means that it's gaining electrons. That's called a reduction reaction. Okay, oxygen 2 giving us 2, oxygen 2 minus. If this is 2 minus over here, therefore it has to be 4 electrons on this side. So what it's basically telling us is that when we balance these equations, we balance the actual number of atoms and also we balance the charge. Okay, so here the total charge is 0 on this side. On this side it has to be 0 as well. How is that possible? If we have 2 times 2 plus, 2 copper 2 plus ions. So therefore they have a total charge of 4 plus. Okay, they have a total charge of 4 plus, and then we have plus 4 electrons which are negatively charged. These cancel out, giving us a 0 charge total. Zinc transfers electrons to copper. Remember when we saw this example in the previous lecture? So we have zinc solid has the ability to give out 2 electrons. So if it does, if it's losing electrons, it's being oxidized. And then copper, which is in solution, is gaining electrons. Copper 2 plus is gaining electrons. It's in solution, so it's liquid, it's an ionic form. It gains those 2 electrons and it turns into a solid which deposits on this layer, and this is what it looks like. And this is how rust occurs as well. So in a single replacement reaction, zinc, which loses electron, is oxidized to zinc 2 plus, which is released in solution. And that happens when it provides 2 electrons to reduce Ca2 plus, which is the reduced reactant, to copper solid. Here's a sample question. So we have Sn giving us Sn4 plus 4 electrons. So you can see that this is losing 2 electrons, or losing, 4 electrons to give us this ion plus 4 electrons. Loss of electrons is an oxidation reaction. Fe3 plus 1 electron giving us Fe2 plus. So this ion is originally an ionic compound. It's originally an ionic component. It's an ionic, it's an ion, it's a cation, which has lost 3 electrons. Now, if it gains 1 electron, it will have a 2 plus charge, right? 3 plus minus 1, it will have a 2 plus charge. So the process of gaining electron is called reduction. Okay. What about this process? Cl2 gas plus 2 electrons turns into 2Cl minus. So this is the process of gaining electrons again, and this is a reduction reaction. Another sample question. In light-sensitive sunglasses, what we have is UV light initiates an oxidation reduction reaction. What happens is that we have this silver ion plus 2Cl minus. In the presence of UV light, we have 2 silver plus Cl2. So what's happening here? Silver ion is turning into a silver solid. The silver ion has a positive charge, and then it's becoming a solid with a neutral charge. So that means, has it lost more electrons or gained electrons? When a positive ion turns into a neutral ion, it means that it has gained or 1 or more electrons, depending on the charge. In this case, if it's just 1, then it gained an electron. Now what about Cl minus? Cl minus, it was minus and then it became neutral. If it is minus originally, it means it's a negative ion, and it becomes neutral. So in order for it to become neutral, it has to lose that excess electron that it has gained. Okay? So which reactant is oxidized? The loss of electrons is Cl minus, it lost its electrons. Ag plus is the one that is reduced because it has gained electrons. Okay? So 2Cl minus, again, before we write the oxidation and reduction reaction, we have to balance our entire equation and then write the individual. So 2Cl minus given us Cl2 and plus 2 electrons, because each Cl has 2 electrons, right? Each Cl minus has 1 electron. So therefore, if we have 2 Cl minus, then we will have 2 electrons generated. Which reactant is reduced? Now we have silver plus giving us, so 2 silver plus giving us 2 Ag. So if each one is positive 1, how many electrons does each one gain to become neutral? Just 1. So therefore we have 2 Ag plus 2 electrons, because each one needs 1, giving us 2 Ag. So the characteristics of oxidation and reduction: oxidation is the loss of electrons, reduction is the gain of electrons. In an oxidation, it may involve the addition of oxygen or the loss of hydrogen. So if we have an addition of oxygen to the actual element or the compound, we say that it has been oxidized, or it has undergone an oxidation reaction. If we lose a hydrogen, it's in other words, just like losing an electron, it means also it can be an oxidation. A gain of an electron, it's the opposite. It's the loss of oxygen and gain of hydrogen, and we will see examples. So here we go. We have this two hydrogens in a biological molecule. They are being transferred into this coenzyme, this other reactant. This is how we can see it in the biological systems in our bodies. We have this biological molecule that has two hydrogen atoms on it. Okay, it is losing these hydrogen atoms to go to coenzyme D. If it loses hydrogen atoms, that is corresponding to an oxidation reaction, right? That's an oxidation reaction. This is the oxidized biological molecule. And now here we have coenzyme is gaining two hydrogen molecules, two hydrogen atoms. And so if it gains those two hydrogen atoms, then therefore it is turning into, it's undergoing a reduction reaction. So not only oxidation and reduction involve loss and gain of electrons, but they also involve loss and gain of hydrogen and oxygen atoms. So here we go. Let's see an example, another biological example where we have the oxidation and reduction of methanol, or methyl alcohol. In many biological oxidation reactions, the transfer of hydrogen atoms is necessary for the production of energy. So, for example, the body metabolizes methyl alcohol, which is a poisonous substance, by the following reaction. Methyl alcohol is broken down into formaldehyde and two hydrogen atoms. So in this case, what happens to methyl alcohol? Methyl alcohol gave us formaldehyde, and in the process, it released two hydrogens. So it means it lost two hydrogens. Loss of a hydrogen means it's an oxidation reaction. Formaldehyde plus oxygen becomes formic acid. It has gained an oxygen atom. You can see that how oxygen combined with formaldehyde to give us formic acid. So it gained an oxygen. Gaining an oxygen means it is an oxidation reaction as well. Formic acid plus oxygen gave us 2CO2 plus 2H2O. So what happened here is that, again, oxygen is added to this component, and this is an oxidation reaction. So it added oxygen. This is just very similar to what we would have like in a combustion reaction, right? It looks like a combustion reaction, and in this case, it's an oxidation because it involves an addition of oxygen atoms. The intermediate products are toxic, causing headaches and possible death because they interfere with key reactions, and methanol is a poisonous substance for the body. Characteristics. So the particular definition of oxidation and reduction depends on the process that occurs in the reaction. Oxidation always involves the loss of electrons, may also be seen as an addition of oxygen, or may also be seen as the loss of a hydrogen. Reduction always involves the gain of electrons, or the loss of an oxygen, or the gain of hydrogen. This is the end of this lecture. I will meet you in 7D. Please let me know if you have any questions, and please practice as much as you can from the book. There's a lot of problems there where you can practice balancing oxidation reduction reactions or writing oxidation reduction reactions. As long as you know the oil rig, you are good to go. Thank you. I'll see you in the next lecture.